Now we're going to take a look at exponential growth and exponential decay. The only trick to these types of problems is looking at the base of the exponential term. If that base is greater than 1, it is exponential growth. If it is between 0 and 1, it is exponential decay. Everything else is an illegal base for an exponential. So let's take a look at the first one. Y equals 0.5 to the x. Well, that's our base right there of the exponential term. We know that 0.5 is between 0 and 1, therefore it is exponential decay. Same idea with the next one. Even though our exponent is a little bit more complex here, we only care about the base. So we look at our base, identify that it's 0.5, and again, we're going to know that it's exponential decay. For the next one here, we have 1.5 as our base. 1.5 is greater than 1. Therefore, it is exponential growth. On this one, we have some extra stuff going on. 3 times 4 to the 2x. Well, we're only looking at our base of the exponential term. So the number that we care about is the 4. Now 4 is greater than 1, therefore exponential growth. This one here, negative 0.5 to the x. Well, that is not greater than 1, and it's not between 0 and 1 either. So that one is actually an illegal base. If you try to evaluate this, you're going to find that it doesn't work. For example, negative 0.5 to the first power would be a negative number. To the second power would be a positive, and if you did a fractional power, such as a square root, you're going to get imaginary numbers. So you're going to have things all over the map. It just doesn't work. Y equals this one here, 2 times 1 to the x. Well, 1 is not greater than 1 or between 0 and 1, so again, it's an illegal base. The reason is that 1 to any power is just going to be 1, and this would just be the flat line y equals 2. So that's why this is not an exponential function. Finally, y equals 1.001 to the x minus 1. If we look at our base, it doesn't have to be very much more than 1. As long as it's anything more than 1, we consider that exponential growth.